From the massive studios in Raleigh, North Carolina, this is the Cloudcast with Aaron Delp and Brian Gracely, presented by A Cloud Guru, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We are coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina, and we are kind of experiencing a blizzard here in Raleigh. We're getting about 6 to 10 inches of snow today in the middle of the week, which is very unusual, but very, very nice change of pace. So Aaron is stuck in a snowbank somewhere, so it's just going to be myself today. We're breaking the streak. I think we're at 4 for those of you that were betting the over-under on how many in a row Aaron would do. You know, one of the things that we've never really had a chance to do on this show, and we've always wanted to, and there's been a lot of interest from the audience about it, is to really kind of dive into what's going on with Oracle, what's going on with the Oracle Cloud. You know, we talk a lot about maybe some other cloud platforms, but very lucky today to have the opportunity to talk to Clay Magouyrk, who is Vice President of Oracle Cloud Infrastructure. And Clay, very excited to have you on the show. Thanks for being on.
No, thank you, man. It's a huge pleasure to be here, and I'm glad to have the opportunity to talk with you today and the rest of your audience. Yeah.
So, you know, like I said, we've had a lot of people over the last couple of years say, hey, you know, why don't you guys cover the Oracle Cloud some more? And, you know, part of it was, you know, sometimes when you're working with big companies, it's trying to find the right people, and sometimes the timing needs to be where it is. But you've been at Oracle for a couple of years now. You had some very, very interesting stuff you were working on in the past from a cloud perspective. Give folks a sense of, you know, what have you been working on both at Oracle, but prior to coming over to Oracle?
Sure. I joined Oracle 3.5 years ago. Before that, I spent 6 years at Amazon. My background is as a software developer, so mostly the relevant experience I had at Amazon Web Services. So I was there when we started Elasticache and shipped that. I worked on RDS, the relational database service, for a while. I also worked on SQS, the simple queuing service, and SNS, the simple notification service. I did a few other things at Amazon before and after that. But then I had the opportunity to join Oracle 3.5 years ago, and it was an opportunity that was a bit too good to pass up. And so I switched over and started working at Oracle. When I joined Oracle, as I said, in 2014, there were about 5 of us in this new office in Seattle. And so it was very early days and had a lot of opportunity to kind of define where we were going and see what was going to happen. I originally came over to do at the time, which was mostly to focus on a couple of services, focusing on identity and access management, and then also to build some block storage for the Oracle Cloud. But that project actually became much larger in scope, and over the course of several years, turned into Oracle's new cloud infrastructure platform, which is called Oracle Cloud Infrastructure.
Right. Yeah, and we've heard stories about that. Kind of heard rumors about it being built. I know we have a friend, Leo Leung, who had gone over there at some point. So yeah, give us kind of how it got started and where it is today.
Sure. So Oracle has been in the cloud business for quite some time. They've been a very large software as a service provider for many years. And then like many companies that come from their background, they started at the SaaS layer and they moved into the platform as a service layer. And they were a late entrant into the infrastructure business. And so they had acquired a company called Nimbula, which was a startup that Chris Pinkham, the original founder of EC2, had gone and started after he left Amazon many years ago. And he had a lot of Amazon connections, and that's actually where he hired some of the first people. I didn't know him, but, for example, he hired my boss, Don Johnson, and he also hired another guy named Craig Kelly. And so we started up this office in Seattle, and as part of that, we came to the conclusion that to really take the cloud to where Oracle needed it to be, we had to really do a big new investment. And so while originally we had joined to focus on a couple of services, we took a step back and said, hey, what if we really took a ground up rethink? And so we started with, new physical data centers, new physical networking, new operational practices, and also an entirely new set of hardware primitives and software layers up above that. And we wrote up kind of where we thought that should go, and we pitched it, and we got greenlit. And then over the course of about a year, culminating in March of 2016, we opened up our limited availability release of our first kind of region in Phoenix. And then later that year, at Open World of 2016, we launched the what was then called Bare Metal Cloud Services, but is now called Oracle Cloud Infrastructure. We launched that publicly.
Right.
And then since then, we've been moving very quickly. We about a year ago we had one production region. Right now we have 3 production regions, and one more will be coming online in February. The team has grown enormously in size. So as I said, originally our started with about 5 people in Seattle, 3.5 years ago, and now I think we have over 1,500 people in downtown Seattle.
Wow.
On this project. Yeah, wow. It's a crazy ride.
Yeah, no, that's a huge amount of growth and a lot of headcount. So I'm curious, before we get into kind of some of the what it looks like when you guys were first getting started, when you went through that, like you said, that sort of bigger picture process and it got greenlit. I'm curious, publicly, we hear, when Larry Ellison gives his keynote every year at Oracle Open World, he always kind of highlights Amazon Web Services as the thing that, in some cases, he wants to make comparisons to. We're going to be less expensive, or we're going to be faster, and but on the flip side, and Amazon's cloud is built a certain way, right? It was sort of built from early on to be around, sort of cloud native applications and, built in the web applications, and they've had to evolve, to do more enterprisey stuff. Oracle as a company, not so much your group, but as a company, has huge installed base of, Oracle databases, Oracle applications. Customers have a certain expectation of, kind of how those work. And I know Oracle has also, always said, hey, we're very interested in helping customers move applications to the cloud. What kind of guidance did they give you as you were building out this new, like you said, bare metal cloud at the time, cloud infrastructure now? Like, was there guidance that said, hey, you have to skew it more towards being able to migrate existing applications? Was it, target more new applications? Like, how do you go about thinking through that kind of architecture when you have, 2 very different types of applications pulling at what could be your architecture?
Yeah, I think that's a very good question, and I'll try to give you the perspective then, as well as kind of how that perspective has evolved over time. So, having been in AWS, and not just me, there's a lot of people who work here who were early people in Amazon Web Services. The original design point was, a couple of people in a dorm room. And so that's typically focused on new applications that you don't have a lot of legacy and you can do things a new way. The huge thing I wanted to focus on when I came to Oracle was, yes, Oracle is a specific company and Oracle has a long history of database customers, et cetera. But the market that I feel like is underserved is that the vast majority of server-side computing still occurs in private data centers. Right. Right. If you look at even the number of servers shipped every year, even the majority of servers are still not shipped to cloud providers. They're still shipped to on-prem locations. And so what that means is that a lot of the benefits of the cloud aren't available to a whole lot of workloads. And so one perspective on that is to say, hey, those people they haven't gotten the message yet. They're not smart enough to do it, or they don't realize how great this new thing is. But that argument kind of falls on its face when you talk to people where they really want to move to the cloud, but they have a lot of barriers. And so the big initiative was, well, how do we build a cloud to enable those people to move any of their workloads, to move anything they have to the cloud? And that attacks all layers of the stack, but we knew that we had to build it from the infrastructure up. And that affected a lot of our decisions, both in the product definition itself, but also in the underlying architecture and implementation. So, for example, one of the reasons that we started off by doing bare metal was not because we think that every customer wants to run on full servers. Virtualization is an amazing technology, and I think the industry and society has shown there's a lot of value for that. But instead, it's about, there are a bunch of things that only run on bare metal servers. Mm-hmm. Maybe you have a custom hypervisor, or maybe you need to be able to control certain BIOS settings, or maybe you need extreme performance that you can only get with direct access to hardware. in those cases, we found customers who couldn't move, and so we said, let's take a step back and make sure that we build the foundation as deep as it needs to go. I don't ever want to have a problem where somebody wants to bring something and it's because we didn't go deep enough. So we started with bare metal and focusing on things like off-box virtualized networking. From there, we also made a bunch of choices around which type of virtual network we would support. So, for example, most public cloud providers only support a virtualized layer 3 IP network. Mm-hmm. But then you look at a lot of, say, existing workloads, and they do a lot of things like gratuitous ARP or MAC address takeover. They require certain L2 features. And for people to be able to move those workloads, they often have to rewrite those applications, and that might work great. Maybe you don't even, if you have the source code and the developers, but a lot of enterprise applications, people may not have the source code anymore. It's something they bought from a vendor and they can't modify it, or the people that would make changes to those applications are no longer available or they don't work there. So we attacked it at every layer of the stack, from the way we offer compute to the way we offer our virtualized networking. We made choices around the way in which we would build storage, specifically around a lot of the storage choices that were made by other cloud providers is kind of around applications that can deal with performance variability. So we have what we consider to be the best-in-class block storage offering, which offers incredibly high IOPS, very low latency, very high throughput. In essence, it's comparable to what customers expect out of an enterprise SAN. But we offer it at the same, just-in-time provisioning, very pay for what you use, and truly low price that you get out of a traditional commodity cloud block storage offering. And so as you go through every piece of every product that we built, you can see the differences. Even, for example, the way in which we treat local disk storage. So as you and your audience knows, the hardware advances that have been made in the past 5 years in terms of, SSDs were available, and then NVMe SSDs came out, and things like, NVRAM and 3D Crosspoint, et cetera. What's happening is that you can no longer just virtualize everything. If you want 4.5 million IOPS out of a server, you can get that by plugging in some NVMe SSD drives. And so when you look at a lot of the existing cloud providers, they offer those. But let's say that you have 30 terabytes of storage on a host, and one of those drives go bad. What most cloud providers do is they say, well, you should have architected your application properly and just throw that host away and get a new host. But when you look at a lot of existing enterprise applications, that's not how they were architected.
Right.
They don't have an easy ability to throw a host away and just replace it. And so what we've done is we provide guidance on how to do things like, having RAID support at the operating system level. And then we also have things like a hardware repair SLA and the ability for a customer to say, hey, that SSD went bad. Could you please replace that? And then we have a timeliness guarantee on how we'll replace that. And so any one of these single features does not actually end up being all that compelling, right? You don't make a decision about a cloud provider based on any of those individual choices. But the net effect is that when we talk to customers, especially customers that have a lot of existing workloads, we enable them to move to the cloud much easier than a lot of existing clouds. Right. And I know I'm talking a lot, but I want to make sure I fully answer your question, because the other piece of this is, however, those same companies, while they want to move existing workloads, they want to build new workloads in the cloud, and they don't want to build them the old way, right? People want to be able to bring their past, but they want to be able to build their future.
Right.
And so to do that, you still have to offer all of the great benefits that people expect from the cloud. You need to be able to spin up a VM in less than a minute and be able to tear it down. You need to be able to pay for just what you use. You need to have elastic resources. You need to have the value-added services on top. You need to have, configuration and orchestration tools. You need to have chef support. You need to have all of the new things as well as all of the old things.
Gotcha.
And so what we've done is we've really chosen, it's not about not enabling the new workloads, right? And we can go into details about, hey, how do we think about containers and Kubernetes and Docker, and how do you think about things like serverless? But you can't just focus on those, because when your clients have, this, the vast majority of money that's spent on IT every year is not for new applications. It's for existing applications and maintenance on those. And that's where we can actually help the customers and make their lives easier.
Right. Yeah, and that makes a lot of sense. I think everything in IT is really, you're never at a shortage for which technology you can go pick and choose and so forth. But a lot of it has to do with, what the timing of what makes sense for my business now, what makes sense for the skill set we have, what makes sense for the applications we have. And I think what you're really highlighting is, given a whole bunch of different choices that you can offer customers, you want to make sure that, for definitely a set of customers who say, look, we have certain kinds of applications, we have certain expectations of the environments, of the network, of storage, and so forth. You're going to make sure that they're not having to sort of cut corners, if you will, just because they're moving to the cloud. You want to give them an experience that they can expect, an experience that they're sort of used to, and deal with, like you said, a lot of the limitations they very well may have, which is, I don't have access to that code. Those developers have left. This application can't be changed, and so forth. So now it makes a lot of sense. Let me sort of follow up with that. Looking at just the infrastructure. So obviously, Oracle offers, like you said, you offer SaaS applications, PaaS platform tools, but when I look at just the infrastructure piece of it, even within that, you offer bare metal, you offer virtual machines, you now offer containers as a part of sort of like a Kubernetes service. How do you, a lot of people are struggling with architecting all of those things, even within their own data centers. Like, how do you go about architecting, the ability to automate bare metal, virtual machines and containers? Do you have to sort of build 3 different systems, or is the system just have to be very, very advanced to be able to deal with all those different types of infrastructure use cases?
Sure. Well, I think VMs and bare metal are more similar than containers, and I'll go into a couple of different flavors of that. So I'll talk about bare metal and VMs first. So the way in which we've architected it is that we actually build our virtual machine service. So we obviously offer managed virtual machines like every other cloud provider does, but we build that on top of our bare metal infrastructure. So what that means is that we have a unified control plane. We have obviously a unified API and an experience where, from a customer's perspective, whether they launch on a bare metal machine or a virtual machine, it doesn't matter to them. In fact, most images can boot across either one. That all works. But what we did is we made the choice to build bare metal and then build VMs on top. And so what that means is that our actual VM service is a customer of our bare metal API.
Okay.
And then it acts as kind of like a second layer on top, which manages the hypervisors themselves. How do you do things like bin packing and resource management? How do you do things like workload migration, et cetera, et cetera? A big part of the reason we did that was to make sure that if we can build our VM service on top of bare metal, other people can do the same. That's kind of a core principle that we can see throughout our offering. And it's not so much that we think lots of people will show up and build their own managed VM offering on top of us. But what it really means is that when you do it that way, you don't make a bunch of short-term decisions and hacks that what we find is that over time actually really slow you down. And so instead, if you say, hey, here's this functionality, and you build it in a layered approach, and you cleanly separate those layers, it actually gives you higher engineering velocity and a better separation of concerns between the products. Okay.
That makes sense. What about, you said containers are sort of their own beast. Just give us a sense of how do containers fit into that model of layers and abstractions?
Sure. So containers can mean a couple of things. So what most people mean when they talk about containers these days is some kind of a managed container orchestration service, right? So, hey, I want, Mesos or Kubernetes or something like that. And so what we've done is we've made a choice around Kubernetes because we think it's by far the most successful, most popular, and the best in the market.
Yep.
And so what we have is we manage Kubernetes clusters for our customers, and then we can actually deploy, the actual Kubernetes worker nodes on either bare metal or virtual machines.
Okay.
And so we give that flexibility. So in that sense, the orchestration service is really kind of separate on the side, but then integrates on top.
Okay.
Something else that we're actually working on that isn't available right now, but will be coming out later this year, is a different layer of abstraction for containers, which is in the same way that, bare metal and VMs, we're also going to offer it so that as a customer, you can just launch a container. This will not have, there will be no orchestration around this. And in many ways, if you think about it, a container is not all that different than a VM, except it's lighter weight, cheaper, might have a different billing model. And you would only specify, obviously, the container rather than a whole operating system. But so what we'll offer in that sense is you can have managed container orchestration on the side, but from the same compute API, you can get a bare metal, a VM, or a very lightweight container.
Gotcha. Yeah, and we're starting to see that start to emerge in the market. Is people, developers don't really care about Kubernetes. Sometimes they don't want to have to think about it, and they just say, just give me a container, give me 3 or 4 containers, and that's all I really care about. So it makes sense that you're doing that evolution. Makes a lot of sense. We talked a few minutes ago about kind of like you said, the mindset of giving customers enterprise-like quality, enterprise-like capabilities. As you talk about, multiple regions, multiple data centers, people wanting to have highly available resources and so forth, or geographically dispersed resources, the conversation always comes up about, well, how do we do networking between those? And networking ends up being a really big differentiator for companies, cloud providers, in terms of performance, in terms of, like you said, layer 2 versus layer 3. Can you give folks a sense of how you do, not only like inter-region networking, but also, I know one of the big things for Oracle is, how do we interconnect, say, on-prem resources with cloud resources? Can you kind of walk folks through what's available and what you guys are thinking from an architecture perspective for networks? Yeah,
absolutely. And so, that question covers a whole bunch of different pieces,
sure.
Right? It covers the way in which we actually build our data centers and connect things together, and then it also kind of switches over into the virtualized layer, in which what's the object model and how do we expose these concepts to customers. So I'll start at the physical,
sure, and
then I'll move up into the presentation that we give to customers. So
okay.
At the physical layer, right, it starts with, so we have this concept of availability domains. For everyone else who lives in the world, you should think of them as availability zones, which in effect is a logical data center, but we'll pretend it's a physical data center right now.
Okay.
A large part of your work goes into how you design the physical network within that data center. So I won't get into the details, partly because it'll take too long and also because I'm not actually a network engineer. But the big choice that we made very early on is that within an availability domain, we have a completely non-blocking network. What that means is that from any host to any other host in the network within that same data center, you can get full line rate from host to host. Okay. And that can be happening from all hosts to all other hosts. And so in essence, right, if, for example, in our most recent offering, each host has 2 25 gig network cards, or about 50 gigabit of network throughput to each host. Okay. You can provision any 2 computers, and those 2 computers can talk at 50 gigabit to each other all the time.
Wow. Okay.
The reason we did that is because it turns out that a lot of enterprise customers are used to that level of performance.
Right, exactly.
Now, they aren't used to it across an entire data center, but they have applications that they will co-locate within a rack or within a few switches, and they expect that level of performance. And if what you do is you tell them, well, what you need to do is re-architect your application, once again, it's a barrier to adoption. So we made that choice. Then on top of that, what we have is a concept of a region very similar to like an Amazon Web Services region, which for us today consists of 3 availability domains in a region. And then it matters how you interconnect those. And so what we actually do is we build a ring around those 3 availability domains, and we connect them with fiber. Mm-hmm. We make sure that all the traffic between those, as they leave the data center, is fully encrypted. And then we make sure that, over time, that we continue to add capacity such that ring never becomes a constraint.
Gotcha.
Such that basically customers don't have to worry about the bandwidth between those data centers. And we have a goal of between any 2 of those ADs in a region that you can get less than 1 millisecond round trip latency.
Okay.
that becomes your very high availability construct within a region. So then on top of that, how do we do things like connect our regions together? Well, we have a global backbone that connects our regions together. We also make sure that we encrypt all of the traffic across our backbone. And then, of course, we also have a significant amount of internet transit that's available at each region, such that if you're serving things to or from the internet for whatever reason, we also have that available. And so you can think of this as, in a networking term, it's not so much as a region-by-region thing. You end up with this global network that you can connect to, and then things can be routed between them in a very simple way. Another thing to understand about our networking is that within our actual physical networking, everything is virtualized, meaning so our physical networking layer is actually very, very simple. And then we have this overlay network that actually does all of the customer traffic as well as all of our personal traffic. And that's how we can then move up into this overlay virtualized network and offer a whole host of other features. That's where, for example, we offer elastic IP addresses. You can control subnets. You get things like security lists that allow you to control, it's basically a stateful and stateless NAT. You can do things like attach multiple VNICs to a single computer. It's, all of the standard kind of features that you expect. And we also will be launching in a few months some novel features in the virtual networking space, which is things like we already support gratuitous ARP today, but MAC address learning and other L2 features that are very valuable for existing applications.
Interesting. Yeah.
On top of that, we offer a lot of connectivity options. So we offer a VPN as a service so that customers can show up and connect to over a VPN. And I probably skipped this part, but it's important. Everything we expose in our cloud is fully in a virtualized network. So what that means is that a computer or a database or any other kind of a resource can't exist except in a virtual network. And then the customer has full control over that virtual network address range, what they want to expose to the internet versus what they want to expose back to on-prem, et cetera. And so then to connect to that, most customers either set up a VPN or they use a different service that we offer called Fast Connect. Well, Fast Connect is analogous to something like AWS Direct Connect, where you can either do direct peering with us or most customers end up already have like a connection with like an MPLS provider, AT&T, Verizon, what have you. And then they just make a connection with them, and we are already connected with that provider, and then they can get very fast, very high bandwidth, very low latency access to our platform in a fully private way through that provider.
Gotcha. No, it makes sense, and hearing you sort of logically talk about it, and like you said, you do a very good job for somebody who doesn't claim to be a network engineer. But just walking through what you're walking through, there is a very much a sense of there is a focus on bandwidth, which is always important to customers. You allow people to not have to worry about physical proximity, even though maybe in their old data centers they had to think about that. So you've architected around those types of things. Like you said, you're architecting to allow existing applications to migrate. So the layer 2 types of features that you can't do in some cloud environments are there. It's a very interesting kind of thought, kind of way that you go about doing it, because I think for a lot of IT people, it's going to check a lot of boxes for what they're used to being able to do within their own data centers. And that familiarity is important sometimes.
It is. And then at the same time, for example, if an existing application wants to do a highly available network takeover by doing a gratuitous ARP, it can. But a new application might choose to use our integrated load balancer service, or perhaps it wants to just make an API call and move the elastic IP address. So we offer the existing technology, and we also offer the new way, which is much more API driven. So I think it's about offering the best of both, because it turns out that people need both.
Right, exactly. Let me ask, we could probably go into a lot of depth on a lot of the infrastructure things. We won't get enough time to go into all of it. I've got a bunch of links in the show notes for people to go dig into things. How do you guys think about it? Because obviously Oracle offers, a ton of SaaS applications, and a bunch of PaaS services. If you're a customer and you're coming in to the cloud somewhere, whether you come in through SaaS or whether you come in through IaaS, like what's the way that I might integrate, PaaS middleware services with infrastructure services? Is it just, I get an IP address or a URL and I can link to them? Does everything go through, does it stay within the Oracle Cloud and encrypted? Like, how do you, kind of walk me through how the different layers of the offerings interact with each other?
Sure. So I think so SaaS is a bit different than the PaaS and IaaS layer typically, right? So typically a lot of SaaS is offered over a URL endpoint, right? You have some identity integration, but that's almost always kind of over the network, over the internet type of a thing, and is more of people interacting with something. And then it's about how do you get easy integration between that and other pieces. But that hasn't changed much for us. Now, we do offer a very integrated infrastructure and platform layer. And what that means to us is that obviously you should be able to come in and consume, for example, things like compute and block storage and virtual networking. But in that same environment, you should be able to provision things like an Oracle database. You should be able to provision things like a Kafka cluster or a Hadoop cluster, et cetera. And so we offer both large-scale multi-tenant systems like object storage, et cetera. We also offer managed services that deploy and operate individual clusters, similar to something like RDS, and we do that for things like Kafka, et cetera. And so we have a suite of PaaS services, some of which are focused on new style applications, Hadoop, Kafka, caching, et cetera, and also a suite of those services that are focused more on existing applications, things like Java as a service, which focuses on web logic, mobile services, integration cloud services. And so we actually offer all of those PaaS services on top of our new infrastructure. And so those things can just be provisioned. They'll show up in your fully virtualized network, and you'll operate them the same way that, customers expect.
Gotcha. And that was, you sort of answered one of the follow-up questions I was going to have are all these new services now running natively on this same, cloud infrastructure? And it sounds like that's the case. Things have sort of been migrated over the last couple of years.
Yeah, so we've worked hard to make sure that we get our PaaS layer kind of ported over first, and that's been very successful. We're in the process of moving all of the SaaS properties over onto us, and as we do that, we'll be able to offer more integration. So you can imagine, you set up Fast Connect once, and suddenly you want your HR application, and now it's not on the internet. You can only access it from your private network. There's a lot of options there, and that's something that will be completed later this summer. But in general, that integration is not is nearly as big a deal as the infrastructure and platform layer integration, and we focused on that first.
Yeah, no, it makes a lot of sense. Listen, Jay, I'm gonna kind of wrap it up with that. We're sort of hitting our time limit. Real quick, what's the best way? If folks want to either reach out to you and your team and kind of talk about kind of what they can do around cloud infrastructure services, or some of the things that are new that people should go take a look at. What's kind of hot and top of mind for you these days?
Well, obviously we love people to reach out to us. So the easiest way to get in contact with us is go to cloud.oracle.com. We have a free trial. We'd love everybody to sign up and use it and play around with the product. And then in addition, there's contact information on the website, which makes it very easy for you to reach out to us, and you can get in contact with our product management team and our support team. And we love feedback, love people trying out the platform, giving us information if you have requests. We're very excited to make our customers successful.
Yeah, no, and we appreciate you coming on. Like I said, we've had a lot of people asking about it. It was good to kind of pick your brain and not only kind of understand, okay, what features are there and so forth, but really kind of understand the thinking that you guys have had behind architectural decisions. Kind of trying to put yourself in a customer's shoes and saying, how do we make them successful? How do we help them migrate? So really appreciate the time today. Folks, with that, I'm going to wrap it up. For Aaron and for Clay, very much thank you for the time today. Folks, thanks for listening, and we will talk to you next week.
Thank you for listening to the Cloudcast. Please visit thecloudcast.net to find more podcasts, show notes, and everything social media. And visit acloud.guru for all your cloud training needs.